Okay, the task at hand is to solve an exponential equation, and the key step in doing such a thing is to isolate the exponential term, if at all possible. And so we would like to get this exponential term. The exponential term is only this 2 that's raised to the x minus 3 power. And so we must then isolate it by getting rid of, doing the opposite operation of the other operations that are on the same side as this. And so we need to deal with the addition of 1 and the multiplication of 3 in the following order, though. We first must subtract 1 from both sides. What that gives is the single term. Sorry, couldn't find my mouse. 3 times that exponential term, and then that's equal to 63 on the right hand side. This is multiplication, although there isn't a symbol written there. So next we undo that by dividing by 3. And now we have the exponential term isolated. It is 2 to the x minus 3, and that's equal to 21. Our job is to get this x minus 3, the entire exponent, down from the exponent position. The function that allows you to do that, the property of logs, will allow you to do that. And so at this point we need to take the log of both sides, be it log or ln or any other base. It would actually make sense to do log base 2, but a calculator has just log for log base 10 and ln, that's log base e. And so let's just go with one of those, doesn't matter which one. And so we'll go with ln. If you have a equals b, then the ln of a will equal to the ln of b. Okay, well, why do we do that? It's the property of logs that we're going to employ, that the log, or natural log, of anything that is raised to a power can be written as that power multiplied by the log of the base. And so we can take this exponent, x minus 3, and we can pull it down in front. It is the p that is in the formula. We can pull it down in front. When we do that, though, because it's multi-termed, we'll use parentheses, and we can say that x minus 3, quantity of x minus 3, times the natural log of 2 is equal to the natural log of 21. Okay. Then we have a couple options of where to go next. We could divide by natural log 2, or we could distribute the natural log 2. So let's so we could distribute the log 2 across. Let's go ahead and just divide by log 2 on both sides. It's a number, and so we can divide by it. There's no property that will allow us, however, to combine these two logs. And so what we'll be left with is, let's go up here, we have the x minus 3 on the left hand side, and then the division of the two logs. We have the natural log of 21 divided by the natural log of 2. And so we need x, and we'll just add 3 to both sides. Okay, so this is some number, and we'll just add 3 to it. And we'll have what x is. So x is equal to the ln of 21 divided by the ln of 2, and then we take that number and we add 3 to it. Okay. And if the question asks for some decimal approximation to this, then we can go to a calculator and get that. So we have clear this out, the ln of 21 in the parentheses divided by the ln of 2 in the parentheses. I like to do it in 2 steps, so I'll hit an enter here, and then I add 3 to that. And so what we get out is 7.39 if we're rounding to the hundredths place. Okay. Alright, great. The key is to isolate the exponential term.